when it comes to talking about your graphs and tables, basically the steps you have to follow fall into 3 different steps. You have to, for every table and graph, talk to me about what trend or pattern or what information you can generally see happening on your table or graph. Then you have to get into it with more detail, describing specific groups of data for me. And then last but not least, you've got to tell me how does this fit with the theory that we've learnt in class. They're the 3 basic steps. So I've drawn a quick table up here to start. This is my control group and 2 other groups. So it could be yeast on its own, and then I've added something to the yeast, and then I've added maybe even more of something to the yeast to see if it has a greater effect. And sure enough, it does. You can see my average amount of CO2 bubbles have gone up. I have a standard deviation of 2, 2, and 3, and a range of 4, 4, 6. So that to me looks like whatever I'm adding here, it's definitely helping the yeast. Okay, so if you put that onto a graph, you could either have a column graph or a line graph, depending on which one is more appropriate. So now you have to look at the trend or the pattern. Now with both of these, we can see that there's definitely an increasing relationship there, because as it's continually getting bigger, there's no real pattern of something repeating over and over there. You could even go as far as to say that seems to be a very linear relationship there, because it seems to be like it's a straight line. But sometimes you'll have graphs where your data seems to go up like that or down like that. We call that curved. Or if you have graphs that go up like that or down like this, we call that curvilinear, because you have some sections on there where it's straight and then it curves and it's straight again. You can just summarize what type of relationship you're seeing, whether it's straight, whether it's curved or curvilinear. The next thing you have to do is describe in more detail for me what you see here. So this has to be for every group or in there, including its range. In the table, you need to summarize up for, I'm just going to blow this up here, for these data points here. So you have a control which is valued at 10, plus or minus, now you have to think about this, plus or minus the range of your data, because that's essentially 95% of your data right there. So you might have had an average of 10, but it went up by 4 and down by 4 either side of that. Okay, so when you had your when you had all of your data points, it actually had quite a lot of variation in there to begin with, and you have an average in here of 10. So that 10 went down to 6 and up to 14. So it actually had quite a big range when you think about that. On your graph, you'll actually be showing that as well. When you tell it to plot the error lines and you use your range, that means it's going to look like this. So 6 would be here, 14 would be about there, and that would be the sort of thing that you see on the range of your data. Okay? It just helps you to realize that you didn't just get a value of 10. You actually had a very large range of data that went like from 6 to 14. Now that same range was found on this next one here. It had plus or minus 4 as well, which means that there's an area here where they actually overlapped. Okay? That means there was some data here that was the same in your control group as with this group here in number 1. Okay? That means you've got a bit of error there, because if you have an area of overlap, that means there's some data points that were the same for both groups. The data in this group here was not completely unique and different to the data in this group here. So you definitely have some error in there. Okay, so back to what we do next. So you describe in more detail each one of these groups. So for your control, you describe your average plus or minus for each one of these. Group 1 was 16 plus or minus 4, and group 2 was 20 plus or minus 6. Okay, that's what you do for your table. For your graph, you can actually put that in as well and describe that as well. And then last but not least, you have to point out any large errors that are in there. I shouldn't say last but not least because we're not quite there yet, point out any large errors that you can see in there, especially if you see, like in here, that there's an overlap. Point that out. That's important. And then you have to try and apply theory. You have to talk to me about, does this fit with the theory of what we were investigating? So you guys, it was the yeast, fermentation. Does this fit with what you were investigating? If you thought that this group here and this group here had some sort of nutrient added that was actually going to improve the way they were growing, then you talk about whether or not this data supports the idea that this nutrient here was going to help them ferment more or not. That's essentially what you have to do. You have to talk to me about how it fits in with the theory. So that is pretty much giving me the interpretation of your data in a nutshell. Okay, just set it up like that. Explain, follow those 3 steps there, summarizing what you see overall, describe each one of the groups for me in detail, point out the errors, and then talk to me about how this fits with the theory. That's essentially all you need to do for now. Good luck.